This is old electronics fan. All right, well, this is part 3, and as you'll hear in a moment, I spent a huge amount of time trying to figure out why the schematic didn't line up with the radio. And, well, it didn't line up with the radio because this is not an R32 or an R36, it's an R35. I came up with the R36 number. If you've watched the previous videos, you'll know that I misread the chassis number as a model number. Anyway, I spent a whole boatload of time trying to see why I wasn't able to figure out what was going on with this thing, why nothing lined up, why nothing matched. It was very frustrating. But I finally got a clue. I finally did a search. I finally found the correct information. In fact, it was a complete service manual for this radio. So I know that will be helpful to anyone who winds up working on one of these, because if all you have is the schematic for this, you will find it to be a serious pain in the butt. Very difficult to do. You really, really, really need the service manual when working on one of these. There's just a whole lot of stuff you will miss that you won't know if you don't have it. So with that said, we will go right into my rant about all the time I spent with the wrong schematic. Well, I have spent way, way, way too much time trying to figure out what's going on with this wiring, this radio, because nothing made sense. And it didn't make sense because the model I thought this was, which is very similar to another model, this thing is not an R32. It's one of these three. It's a 35 or 39 or 57. So I kept saying, this circuit diagram doesn't make sense, this circuit diagram doesn't make sense. And I should have spotted this sooner, but I kind of thought, I was thinking that I lost track in the middle of my sentence here. I was thinking that, well, I was convinced that this was a Model 32. But what I didn't pay attention to was the fact that this radio has these are 24s. The radio, the 32 model, has in it Model 26 tubes. Oops. There's it. So in the Model 32, 1, 2, 3, 4, those are all 26s. In this one, and I'm assuming this is a newer model, these are all 24s. And the difference is that the 26s are 4-pin tubes, I believe. I can't remember if they had a cap or not. This, if you add the cap, this one got 5 pins plus the cap, so 6 connections. So, and I was starting out here with this tube, the Model 27, or the 27 tube, because that is the only tube that I can get to the bottom of the tube socket on. I'll show you why in a minute. The other thing that kept driving me buggy was this right here. They kept showing a connection here of 15 pins or 16, I don't remember exactly, just lots of pins. I have a total of 7 here. The connector is an 8-pin connector, but there's one of the pins is not used in this particular model. Because there's also a version of this that has a turntable in it. So I'm assuming the 35. I'm assuming this is the 35, and then either the 39 or 57 is the one with the radio, the turntable in it. And if you look up here, This is all related to the turntable. Whoops, I gotta pay attention. This is all related to the turntable. And there's a couple of jumpers that I didn't know what they were, and they're on the top of this chassis. And I saw those and I thought, what are those for? Well, I now know what those are for. And they were both jumped, which obviously makes sense because this doesn't have this. And this is also something else that you have to pay attention to. There's another link somewhere. I don't think it's in the same spot as that one, but that one is also jumpered because it's just a radio and not a turntable model. So, this is now making a lot more sense because I found this capacitor and this capacitor connected to this tube, but they weren't connected to the right pins based on the circuit schematic that I was using originally. Of course, I now know that they are connected correctly and the circuit diagram is not wrong. And not only that, I've been able to find out what the values are for these two. The only way you can get into this is you have to take this cover off. And that's going to be fun. You have to take this cover off, unpot the original capacitors, disconnect them and put new ones in. So that's what I'm going to do first. You have no idea how much time I spent trying to figure out why this capacitor was wired up to these two connections and not where it was supposed to be. No, it wasn't supposed to be. So it's challenging. So I guess the thing I've learned is when you find a schematic, confirm that the tubes that the schematic talks about are indeed the tubes that are in your radio, because it'll save you an awful lot of grief. That was a huge mistake. But in my mind, this was a model 32, and I tried searching for the chassis number, but the chassis number was on the amplifier, so I don't believe it would have helped me all that much. I gotta remember to tighten it. Yeah, somebody had their digits in here because that screw was loose. The other thing that I've noticed is that this wiring is really faded. Let me show you why I think it's been faded. Look at that wire. That's bright. There's a cover that went over this. That wire and the wire underneath it, the colors are vibrant and very bright. Once they leave that cover, where that cover was, they aren't so vibrant anymore. They're all faded and washed out, and they give you color codes for this, but I really think this radio sat about like it's sitting right now, where the sun could get at it and just bleached. Because it's supposed to be green over here, and it's just gone. So I was getting very frustrated, but I've got a ton of information now that can help me with this. Because there's something else that would drive you batty. It's driving me batty. You notice there's only one socket showing. Well, maybe you didn't. There are 4 other tubes in this radio, and not a single one of their sockets shows up down below. They sit above this separate plate, and you can see the wires going to one of the tube sockets right there. But you can barely see the socket when you peer through there, and I think there's another one up here. So having color codes would have been very, very useful. I'm toying with the idea of using, I have some paint that I was using for marking cables on one of my old radios. The antenna wires were all faded, and so I wanted to make sure I remembered which wire went where. So I have at least 4 colors, so I use those to create dots so I could match them up again. So I may possibly, if I get into it that deep, I may possibly mark some of the wiring with dots on them. You know, maybe 2 yellow dots on the ends of one, and a green dot, and whatever else I've got. I don't remember, white. Because these are in pretty sad shape, and I can sort of see there's black mixed in with that one. But it's pretty had it. So now that I have the right circuit diagram, the right information, I can actually work on this radio. And let's see, this, okay, that's fine. And the other thing I'm trying to do is I'm identifying what pins go to what connection. Yeah, once again, I've got all of the individual pins marked with a number, because I know that pins 1 and 4 are the filament, and I can use the filament connection to figure out what the socket pins, the rest of the socket pins, what they are. So I know what goes where, and I can trace things better and all that sort of thing. So this has been interesting, and I knew these were 24s. I knew they were, but I didn't pay attention to the schematic and what it was detailing out. And finally, the old light bulb dawned dimly over my head, and I thought, wait a minute, what tubes do I really have? And then try to find this. I actually stumbled onto a site, and I should probably put the link up there. Exceedingly helpful. And I found an RCA service manual for the 20s, I think, up to 30. This site has a bunch of stuff. I really have to make sure I put that link somewhere on when I put this video up, because that saved my bacon, to say the least. Because I could not find this. I tried searching by tube complement. I tried searching by the chassis number, but that was, I didn't think about it. But that chassis was the amplifier chassis, and because they are 2 separate components, that would not have helped me find this. Although it seems like that chassis, that amp chassis, and this are linked together. But anyway, so finding that service manual, and I had to go through the entire service manual. It was at the very end that I found this. So fun times. All right, so I'm going to. I'm not going to inflict on you me taking the cover off from this, cleaning out the gunk that they've got in there, and putting in new capacitors. And I'm gonna do that with all of these, because I've tested these already with my tester, and pretty much all of them are unhealthy, at least in part. So I really wish I could flip this on its face, but I'm a little nervous about doing that. So, although maybe, well, anyway, I'm not going to bore you with all of that. I am going to see what I can do. Oh, so another thing about this radio, if you're thinking about getting into one of these and restoring it, let me show you something. Because this is also fun. Now, let's see how close I can get. Alright. See that little wire poking out of here? There's another one on the opposite side down here, which you can't really see. There are 1, 2, 3, 4 resistors hiding behind this plate. Oh, and the other thing about this radio, and you have to remember this is very early, this is, see this? this is a connector similar to all of these, and you notice right now I can stick my pointer through there. What they do, and this is what's going to make it really fun when you go to take stuff out of here if you need to disconnect a wire for some reason. What they used to do was they would put the wires in and they would squeeze them together so that now this is clamping the wire in place, and then they would solder it. So now what you have to do is you have to heat up the solder, get a small screwdriver, pry this thing open, and then you can take the wires out. I'm really, really, really glad they don't do that anymore, because that's not nice. And everything in here is done that way. So, the fun continues, and I gotta put that back where it belongs. It looks like somebody has been in here and worked on it, because this resistor has been somebody just put the lead on there and soldered it, which I'm not unhappy about that, but it looks like this one up here is the same deal. So somebody's worked on this at one point. Some of the resistors apparently were unhappy. So when it comes time to check values on these resistors, I can probably just unsolder it, check it, and do whatever needs to be done. Oh, and yes, this little plate right here, it is riveted in. See, rivet? So you can't even take the screws out and flip this forward a little bit to get at what you want to get at. That's not an option. So, like I said, if you're thinking about getting one of these and working on it, and you don't like dealing with stuff like that, pass this one by. This is still a fascinating set. And I just am amazed that they did this for the tuning. This is so engineered. This is so insane. And I think now that I've got this fixed, yes, oh, that's much better. Yes, the oil has worked its way in there, and that feels just like all the others do. Very nice. Yes. Yeah, so I think we're. That all looks good. Yes. That's a little bit stiff, but not bad. I may put a few drops of oil in that one. Although it looks like some of the oil. Did I oil that? I don't know. Well, anyway. In any case, so there's it's definitely an interesting radio, and it's definitely much more possible to fix this now that I have the required information, i.e. the right schematic diagram. But what's probably really going to be helpful is stuff like this. There's a bunch of information in the stuff I printed out. They've got troubleshooting notes and all kinds of things. Very handy. Wish I found that before I found the wrong schematic. I don't even want to say how much time I spent trying to figure this out. It's a good thing I didn't record it. Alright, I shall return. So basically all I'm going to do is I'm going to go through and find out what each of these capacitors are, replace them with the appropriate capacitors, and then I'm going to put this back together, because I think this is overall in pretty good shape. I don't think I have to do anything with anything here. From what I can see, it's all in pretty good shape. I don't believe I'm going to have to do anything here. So And I've temporarily found a knob that allows me to use this much more easily. So, and it seems to work. It seems to work properly now. I did find pictures of the knobs, and they are not as decorative as I thought they were, but they're definitely a lot better than these knobs that I found. And these were on my Philco Butterfly radio. This was the wrong. These were not the right knobs for that. So anyway, all right, I'm wandering way too much, but I shall return. All right, well, I decided to pop back in to show you a few things. It's always interesting when you're doing something for the first time, and it is my first time of working on one of these radios with this style of capacitor. This is the capacitor that came out of here, and I don't know what they used. It almost looks like some kind of a rosin. When you heat it up with a soldering iron, it melts. I don't know, but it really does seem as though it's a rosin type of material. And there's one capacitor hiding there and one in there, and then there's a little strap in here. The strap was stuffed up inside here, providing the common ground for both of these capacitors. Yeah, what's it say? Nothing helpful, I don't think. But that's, of course, one of the capacitors is a 1 microfarad, which is what this is. So that's part of the reason why this thing is so fat, I'm thinking. Especially given the technology of the day. Usually our modern capacitors are a lot smaller than the old ones. And I guess put that alongside there, yeah, it is a lot smaller. But anyway, so it's interesting, but I've also discovered that sometimes you can get away with not prying these apart. I mean, this one I had to. This one slid out. That one actually slid out over here. That one I was actually able to heat that, and they just slid right out. So they're not as bad as you might expect. Of course, the fun part of this is going to be that I'm going to have, well, I've got a ground right there, so I could run my ground up there, I guess. But then I'm going to have to secure this. They didn't make it easy. If it weren't for the fact that I wouldn't have a good way. Now I do have some pop rivets that possibly I could use to put those back, but I'd rather not do that. I don't have any rivets of the type of the style that they have. So what I'm going to have to do is I'm going to have to secure this side of that together. And probably what I'm going to wind up doing is running a small piece of wire up here so that I can slide this in without having to fight with the fact that the because having these connections on that end, it would have been so much nicer to have them this way. But I can't really turn it around because all the wires are cut for that location, for that they're the right length for that location. Oh, and yes, I had to pry this down, unfortunately, to get this out of here, because hiding right here is a thick bundle of wires which wouldn't let me lift it up. Of course, getting it to come apart from there, that wasn't easy either. So it was a bit of a challenge. But and I'm putting a piece of filler material in here because now I've got that out of there. It wouldn't. Without that in there, this would just drop down inside there, which is not what I want. And of course, because this is sticking down, I'm gotta jockey this back in and make everything fit. So yeah, fun. So anyway, so I wanted to show you this a little bit, and then I'm just going to do the rest of this and I'm not going to come back and show you that part. But it's definitely, these are definitely interesting, because once you solder them together, trying to get them to pry apart, it's not entirely easy. So you have to clean these up a little bit so I can get the excess solder out of there, I guess. And then put it all back together. Alright. Alright, I'm back. I had not planned on being back until I had done all the capacitors in this and was ready to move on to the next thing. But I ran into something that, well, a couple of somethings. One of them is definitely my mistake, completely. But then the other one is I'm sort of half and half on that one. And I don't know, there's something else I probably got wrong. I'll try to remember that as I go through this. But, alright. The first one is partly the fault of the documentation, and I'll show you why. Let's see, can we? Let's see, I'm going to zoom in. Yeah, I figured it was going to do that to me. So I'm looking for, this one is 43, right there. Let's see if we can zoom in on that one. Alright. Now, I'm happy to have this documentation because it saved me a lot of grief in some ways. Because I've got, let me back up a minute here. Alright. This stuff is definitely very useful. It tells me what's in each of the capacitor blocks. There's one there, one there, one there, one there. One, two, three, four. Yes. And so it's nice that they tell me what's in each capacitor block, but this is not so nice. Notice what it says. 3 units of 0.1, which is right. I've already measured, and actually the values aren't bad in that particular little block. Each with a common ground. Alright, here is how I interpreted that. Ignore this part for a minute. That's how I wired up the previous block that had that description. That's what I did. Kind of makes sense, doesn't it? Until you actually look at the circuit diagram and you see this. Let's see. Oh, and this is the one that triggered this. This one, is this the one? Oh yeah, this is the one, okay. This was a 2 capacitor box. And when I was trying, and the information told me what was in the box. Of course, it doesn't tell me what goes where. So I had to go to my parts list, find out which 2 capacitors were the 0.25 and 0.75, find out where they were, and then once I figured that out, or as I was figuring that out, I noticed this capacitor does not go down to ground, it goes to a resistor first. So I said, okay, that's simple. And so I wired up that one correctly. Now I had already done one of the 3 capacitor blocks, the 0.1s. And as I was looking at this, I thought, I wonder. And then I looked over here. Look what I see. I suppose you could call that a common ground, but it's not how I would interpret it. So, this is how I should have. Hey, you got a nice white sheet. Alright, this is how I should have wired that block. I'm going to have to actually go back in and fix it. Because these two go to this lead of this capacitor, and then this goes down to ground. Just like that 0.75 and 0.25. Well, I've got 3 of them to fit in here. And we'll go back here to the schematic, and you will see that that is, oops, wrong way. Go back over here. I spent a fair amount of there's another mistake that's definitely all mine. Can't believe I made it, but I'm going to mention it just in case someone else falls into the trap that I made for myself. Alright, so we go back here, and there's 2 of these. There's this one and this one that are the same wiring. So you'll notice, well, I didn't draw my schematic exactly as it should be, but that's interesting. Oh, okay, yes. Alright, yes, I was right. So this is one of the connection pins on the capacitor block. This is one right here, and this is one right here. And so you'll notice this capacitor does indeed go down to ground, and it shares this connection to the cathode with these 2 other capacitors. And this one goes to the screen grid, and this one goes up through the coil to the plate. Not sure why they did that the way they did that, but they did. So, and what's interesting is when you string capacitors together in series, you cut the value in half. So if you were able to measure between here and here, you would see 0.5 microfarad. And the same would be from here to here. So that's also a clue when you're measuring to see how the block is measured or how it's designed. You should see something similar to that. And so I've used my capacitor tool, my hole peak tool, to check out how, and I really wish I had done this, oops, I really wish I had done this on that first one that I did, and well, I didn't. So one of these 2 is wired up wrong. And I thought about it and said, well, would it matter? And probably, because these 2 aren't going to ground, and so if I were to wire them up to ground, that changes what happens with this coil and that coil, and I'm not sure what that would do. I debated about leaving that one I had wired incorrectly the way it is, but now this has to be going down to ground, this one would be going down to ground. It would actually break this connection between the coil and the screen grid and the cathode, and what do they call that coil? Where is, oh, I think it's here. The coil, which is under here, 45, stabilizing inductor. Alright, so this is called the stabilizing inductor right here. So I'm thinking it's kind of important to have that in the circuit, and if you don't have this wired up correctly, you would drop coils out of the circuit, and that's probably bad. So no matter how much I want that not to be the case, I don't think I can ignore it. So let me just show you how and I really wish, I really wish that I had thought of this sooner. Let's zoom this back out a little bit. Alright, and there we go. And maybe a little bit more. There we go. Okay. So this is the one that I've already done and done incorrectly. I wish I had stopped to say, gee, maybe I should measure this and see how it's wired. But I was relying on the documentation, and well, it's I guess you've got to pay attention to all your documentation. So anyway,
So it occurred to me that I could use my capacitor meter to figure out how this is assembled. So, let me put that over there so I don't block it. Alright, so if I go from here down to chassis, 0.127, thereabouts. It's probably not the best ground. Let's try that one. Same. Alright, so this one is the one that goes to ground, or it should be. Because if I try to measure from here to here, I have 0.06, 0.06. And then if I go to measure from here to here, I get 0.140 and I get 0.137. So, oh wait, alright, so I'm measuring from here to here. So you can see what I was doing. Oh, you can't see that, can you? Alright. Alright, so there's three pins here. And so this one, if I measure from here over to the far right pin, I get 0.137. I go from the middle one to the far right pin, I get 0.140. Now if I measure across these two, 0.69, and across these two, I'm going to do that, or that, and I get 0.066. So it's pretty obvious how this is wired. And if I had done that to this one, I'd have seen that, and that would have avoided having me do it wrong and have to redo it. There's the old saying, we do it right because we do it twice. I'd rather not do it that way, but well, anyway. Now the other mistake I made, alright, so let's pretend there's a piece of cardboard that the pins are attached to. And let's pretend that this is the top of the cardboard with the two connectors. In this case there are just two. If you're looking at it and you know that, say, a 1 mic goes here and a 0.1 goes here, and then you flip it over, what happens if you forget that you flipped it over and you put the 1 mic here and the 0.1 here? Now you've got them in the exact opposite spot. Fortunately, I caught that before I soldered everything all back together, so I had to take and resolder, unsolder, and move things around. Which gets me to the other inversion that I did. In fact, let me see if I can spin this around without knocking things over too badly. Now, remember I mentioned how difficult this is to work on because of trying to get at the sockets? Well, they did make some provision for servicing this. These cans, these included, as you can see, this one is off. These can be, the cans can be unthreaded, and now you have access to the tube socket. And so, and I found out these little dots right here. So I'm going to clean up a little bit, because I think I'm going to be testing some things before I get all done. There's still some things I want to check out because I made some mistakes. Well, I'm not sure, but I want to avoid any future mistakes. Alright, so these little dots actually connect to the socket inside, and you can go either way. You can try to get a probe in there, or you can just touch it here. And it looks like the only way you get these sockets out, should be a lot of fun, is if these tabs bend over. Apparently you pre-wire the socket, you slide it in place, and you bend these tabs over to mount this in place. Very interesting. So anyway, so back to what I did wrong. And that one cost me some time because I was running around in a circle saying, well, why doesn't this, because when I was measuring that capacitor and then trying to compare it to the tube, I kept saying, well, why doesn't that line up with the schematic? How come? Well, it didn't line up with the schematic because when you're looking at a tube socket from the bottom, you're going around clockwise, pin 1, 2, 3, 4, etc. When you're doing it from the top, you're doing it counterclockwise, 1, 2, 3, 4, 5, etc. So I was doing it clockwise on the top, which meant that this is pin, this is the filament, these two pins here. So because I was doing it clockwise on the top, I thought, okay, pin 1, 2, 3, 4, 5. It's not that way. This is pin 1, 2, 3, 4, 5. So I got to double check that I'm reading that correctly. Now that I've screwed myself up on this, actually it's this socket down here, I think. So I've got to check and make sure that I'm not screwing something else up. So now I've got my head on straight, and I'm remembering that I go counterclockwise when you're looking down from the top. Now hopefully I can figure out exactly what's going on and make sure that this and the way I want to wire that capacitor line up with the schematic. And that's the key here. I want to make sure that the schematic and this agree. That's something very basic, and I'm pretty sure that it should agree. There are times when I'm not sure. There are times when I go to find things and I find out that, oh, I must be using a revision. A revision that is not in this particular schematic. Which is, well, those of you who have run into it, that's kind of annoying. So, anyhow. So I'm going to now go back and verify with my correct understanding, and I think it should make sense now, because what didn't make sense was if you go clockwise from the top. Let's see, filament right there. All right, 1, 2, 3, 4. This actually is not 4; it's 2, I think. Yeah, 1, 2. And that kind of confused me, the living daylights out of me. So anyway, so I'm going to confirm, though. I'm going to make sure, because I've made enough mistakes already. Before I go through everything and wire it up wrong again, I'm going to make sure that I've got this right. But now, like I said, I've got my head on straight as much as I can have, and we're going to hope that I have now got it sorted. All right, so I'm going to. Oh, the other thing. Do I have any way of doing this? No, I don't think so. Maybe not. Well, let's see, maybe I can. I haven't put this together yet because I wanted to confirm some things. So, yeah, you can't see that. There's no way I can get you to see that. These are my shims I'm putting in here so that the cover can be held in place when you push this together. Maybe what I'll do is I'll do this one, and I'll show you what you're dealing with actually shortly. Alright, well, oh yeah. Having gotten reading the tube sockets incorrectly from the top, I was really confusing myself. Let me just show you one last thing before I get into this. I was puzzled. Let me just see if I can. There we go. I was puzzled as to why, let's go to this one right here, why I could measure directly to pin 2. Why I didn't see this coil in the circuit. Well, the reason I was reading directly to pin 2 was because it's reading pin 4, which goes directly to the cathode. So I'm glad I went and confirmed, because I thought, well, maybe that's really low ohms, but I think I believe when I measured this, it said it was 38 ohms, so it's not that low an ohm. So my short check on my meter should not have seen this as a short, and it actually doesn't see it as a short now. So anyway, I should have dug into that a lot further than I did before, and I didn't. So back to this. Now let's go back down here and right there. Okay, I hope I can do this without blocking everything. And I want that. Okay. I've got two pairs of these. This one is ancient. It's been, you can see it's been filed and sharpened over and over again. It's kind of tired. So I decided to buy a new pair of these, and they're in my drawer. But I kept these around. Number one, these are very sturdy. The new one that I've got is actually the second new one, because the first one I overstressed trying to cut a wire, and the cutting cutter went bye-bye. So I'm much more careful with the new version of these. But I keep this around for two reasons. Number one, there are times when I want to cut something, and because this is a bit more dull, it doesn't spit the wire into the wire at you. There are times when I want to grab something without cutting it. I still have to be careful because these are still short enough to cut. But the other ones, forget it. You grab a wire, you're cutting it because it's very sharp. The other thing that's nice about these is that I can get in under, well, can I get in there? Well, anyway, I can get these underneath the edge of something like this and just pry it out, and they work really well for that. And unfortunately, my camera angle isn't giving you much of anything, is it? Alright, so you see this, and then I have these long nose pliers. I can reach in here, and actually this is not the one I wanted to do first. No. I'll do the back one first. I keep forgetting to do that. Alright. So that's the other thing. If you want access to the back one easily, you don't do the front one first. It gets in your way. And then I can get in here and I can bend this out of the way more. Do the same thing with here. Yeah, no, that angle's still not helping much, is it? Well, now get you where I want you. Alright. And even as skinny as these are, sometimes they don't get under there first try. I forgot to check on my card. I didn't expect that. I had that much stored on it, and it ran out. I guess that's the way it is. Alright. Hope I don't have to bend that one too many more times. Now the way this is set up is there's a little metal plate that sits on top of a cardboard piece, which covers the actual capacitor. Now, these are a little bit of a pain to get out, not because they're glued in so well, although it's kind of stuck in there, but because of, well, I'll show you in a minute. Alright. The material that they use to pot these in is fragile, and most of the time, except for when it's soft. But it's not too bad to get out. There we go. Now, this potting material probably has plays some part in why this is so hard to get out, but the biggest problem I'm going to show you in a minute. And this is also what caused me to check more closely the wiring of the other capacitor I have up here. So let's see, can I? No, don't do that. Where'd my wedges moved on me. There. Now, I push that up harder and farther because if I don't do that, let's see why in a minute if I can get it to come loose. There. Okay. In the bottom of these are the ground leads that go into the back, and you can see them sticking out here. Now, on some of these they have one, on others they have two, and on the one up here, which only had 2 capacitors in it, had 3. So I'm not sure how they did this, because it looks like, yeah, if you look at this, it looks like they just wrapped it around a form, wound it, and then squashed it. And so I'm assuming that this was put in at some point in the winding process. I haven't taken any of these apart yet. I might, although there's not much to see. I know what's in there. So now that I've got this out, and I'm keeping these because, well, between the box and the chassis, this thing absorbs a lot of heat. And I have a Weller that's 100 and 140 watts. It puts out a fair amount of watts, and it usually does what I want it to do. I don't always have success. It takes a while, let's put it that way, sometimes to try to get things that are as well heat sinked as this is to melt. I actually did try to heat one of these to try to get the tabs out. So there's a little rivet that goes through. Well, let's see. I don't know if you can see. I don't know what I was. Oh, my rats! My TV turned off. That's why I'm not paying attention. Darn. Come on. Come to life. Let's back this out a bit, because I keep forgetting where I am. Alright. So, anyway. So there's 2 straps in here. I can get them out where you can see them. And you can't even see them. Alright, so you've got these 2 little thin straps that are inserted when the capacitors are being made inside the pack. And then on this side, let's swing this down a little bit. Alright, on this side there's probably something similar that's inserted in this area. And I'm going to try to just cut those. Well, actually there's 2 ways to do this. If you are able to get it tilted up enough and get in there enough, you can try to unsolder them. But the way these tabs are designed, so there's a little plate that comes down. It's got a slot in the side, and there's this flat piece of material that goes into the capacitor is shoved sideways into that slot most of the time, which means that you can't easily just pull it free, because sometimes it doesn't want to. So I'm trying to get down to these. What a mess this makes. Yeah. So, and it's interesting, parts of this material are very brittle and fragile. Part of it feels kind of gummy. So I really don't know what that stuff is. going on here? Uh, It's a bit easier when there's only two of them, but so I guess I'm going to try to get in here this way. Come on, let's go. Yeah, it's weird stuff. Like I said, some of it's very hard and very brittle, and some of it's kind of soft. It'd be nice if it all was brittle, because it comes off pretty easily when that's the case. But it's not going to be convenient for me, I don't think. Yeah, I don't think 100 years ago they actually thought about people taking their capacitors apart and reusing the cases like that. Given how long these things have lasted, I think they were planning on them lasting for as long as the radio was going to last. And it certainly seems to be the case. Now so now that I've gotten into this, I'm able to just go in there and chop this out, because this little metal piece, the little flat piece just comes out and solders onto this. So now I can hit this with my soldering iron and melt away the solder and the junk that's on there, and then I can go rebuild this capacitor. But that's what's inside of these, and you can really see how they must have wound this on a round form and then just crushed it. Interesting. Anyway, let's see. This radio has me using my Weller a whole lot more than I have in a while. I usually use my other soldering iron much more often than this. It's just kind of convenient. I think I mentioned before that I had my cord that was all twisted up and I wasn't reaching. This is my other soldering iron. And, oops, can't get it where I want it to be. It's got the skinny tip on it. All of my soldering irons up till this one were were flat spade-like bits, and I was very used to that between the Weller and some of the other soldering irons I had. And so when I got this one, I fully planned on buying a spade tip for it. But the more I used this, the more I liked it. And it really works quite well. I'm very surprised. It seems to melt the solder quite nicely. And if it doesn't, I just have to bump it up a little bit. But let's see, maybe we'll do this. Alright, so my plan. So anyway, I've found it's very convenient to have that skinny little tip sometimes. Some of the places you're trying to get into, it's not easy to do. So wait for this. This is a Radio Shack tip, and I have a Radio Shack gun that has, it's a plated tip, and it's held up a lot better than these just straight copper ones. I don't think you can get the ones with plated tips, from Radio Shack anymore. So, yeah, come on, or not. There. I don't know if you can see that, but there's a little slot right there. And that's what makes it a little bit of a pain when they stuff these flat pieces of material into the slot, and then yeah, they don't want to come. I tried. One of them, which had only 2 connections on it, I was able to finagle, but doing what I just did seems to be easier. Cut it, and then you can clean it up afterward. I do believe. And so one of the things I try to make sure is that the slots are open, because I do use I curl my wires around the slot. Alright. Now, this is where I've got to remember this. In fact, I'm going to make a note on my thing. Alright. Ground symbol, more or less. Well, that's not a very good one. Another 100 years from now, I want somebody to know that's a ground. I don't know. Anyway, if this radio's around 100 years from now, who knows? I don't know if AM radio is going to be around 100 years from now. But anyway, that's just a reminder. And I'll go back to my drawing. Where do I put that? Down here. And this is how I'm supposed to do that. So I go back to my schematic here. Yes. Zoom in. Is this the one I want? Oh, this is the small one. And this is the one. Well, why not just use this? That's why I didn't have it. It was stuck down on the floor. Alright, so when I look at this carefully, then just again confirming myself because I've made too many mistakes. Alright, so I want to confirm that this reflects that. And let's see, so this goes up to my capacitor, so yes, I think we're right. And this is, I drew this the opposite because that's how this was. Knowing my tendency to make mistakes, I decided to draw this the way it's supposed to be. Except that, no, that's not right. Yeah. Oh, no, 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 no. No, 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 no. No, and no, 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 no. This is the ground. Remember, you're flipping it. Grounded. Grounded. Well, I don't know. This is my last. Well, I got one more to do. Maybe by the time I do the last one, I will get it right on the first try. That would be kind of nice. All right. So, anyway. So so this is the opposite of what it's supposed to be. When I'm doing it from this is correct from the top as installed, but it's flipped. All right. So anyway, so I look at this. And I've got this capacitor, and so these 2 capacitors tie together on this leg goes to its connection, and then these 2 have their individual connections. That goes to 3, that goes to 2. I believe we've got it, by George. And what's nice about this setup is that you have 3.1 capacitors in here, all the same value. So all you have to do is make sure you get this tied together correctly. Now the other thing that I do, or have done, whatever, is this thing. Wow, why is it so dark? I don't know. Can I throw this in here? Yeah, I guess maybe I need a better light. Alright, so this, like I said, I had trouble trying to desolder this, so I'm not going to try again. So what I do is I grab one of these, I put a dab of solder on it, and then I put a piece of wire on and solder to that. And then I solder the piece of wire to the ground of the capacitor that needs to be grounded. And let's see, so I have a bunch of these. Point 1, point 1, So I'm using the orange drops, or whatever we're going to call them. And so what I've got to do is, I'm going to lay this out. So this is how that's going to go, and then this would work like that. Alright. And I didn't get that one. That's what I'm afraid of. When you got too many things on a joint, you have to check and make sure you got them all. And maybe I gotta go from the front with the solder too. That might help. Yes. Yeah, there we go. Alright, so that, take care of that. Oh, hot. And a second. Get rid of that. I just really don't like things lying around and able to do bad things. So I try make sure they can't. Alright, so then we've got this one. That works. Let's get rid of part of that. We don't need all that there. And then we do this one. Alright. That makes me nervous. Because the metal is right there. How does that fit? Oh well, that might be okay, right? Yeah, I think that'll be alright. Always trying to make sure bad things don't happen. If I can avoid it, I'd love to. Okay. I very rarely have cold solder joints. I try to take every precaution I can against that, because they're a pain in the neck to try to troubleshoot. I did have one that I actually didn't get the entire joint warm enough, cracked the old solder, which opened up an intermittent connection. Fun, fun. Alright. Now, I gotta come up with a wire. I've gotta have one somewhere. That's what I should do. So I don't care what color code you are. There we go. And I'm doing this, like I said, I want to have a spacer in there. So I want to make sure that it is alright. So now I thought this light was brighter than that. I don't know. Anyway, not sure if I can get it so you can see me what I'm doing anyway, so. Alright. Somewhere, pin up my tip every now and then. Come on. Way on. Oh. Thought I had the trigger far enough. I didn't. Alright. That doesn't look good. Let's do this. There we go. No. I guess that'll work. I got it tinned. That's what I wanted. So, I want you right there. Come on. What's this? Why are you... It's making clicking noises, leading me to believe that it's actually doing something. I'm not sure it always is. Alright. Alright, so next. Oh, come on. Oh, no. Alright, the extra solder on my tip works really nicely to flow and fill in. Right there, looks good. Then I want to do this. Now, I'm using a piece of wire like this because, as you can imagine, it would be not so much fun trying to fit this all together. Okay, and fit this all together using that short little ground strap. And so far I haven't had a lot of trouble with it, doing it this way. Actually, I should probably bend that one because that's liable to stay put. The other one, maybe not. There we go, I think. Are you there? Yeah, I think so. Good. Alright. Final shot. For this anyway. Alright, I think we're there. Yeah, looks good. So now I can fold this in here and put it where I want. But then I got to come up with a shim. Okay. It probably won't matter. I got plenty of this, so I don't know if it matters. Alright. I'm sure this is exciting to watch. Alright, so now alright, now, so it doesn't matter if that ground yeah, I think that'll work. So all I have to do, all I need to do is this. Let's put this on. Not like that. Why? Are you not? Oh, I have some concern here because this. Oh, I have to clean these off some more. These are bent down more than I want because they can ground out on the case. So, well, let's do some cleaning. Now, the other problem that you run into with this style of connector they've got here is they break. Over here, the part that folds over, far too often it snaps right at the point where it's been folded. So, I mean, it did last all this time, you know. Let's see, I think this might actually, I'm trying to remember, I thought this was 1929, but I think it's actually newer than that. I think it's like a 31. So, it's not quite as old as I thought it was, but it's old. So, let's see, let's say it's 30, 70, 92, so it's 91 years old. That's old. Alright, now dare I this up a little bit? I don't know. Now, I don't want to leave it bent down like that, however, because they don't really give you a lot of room. And I may, on this one, I may actually get a bit anal and I wonder if my wedge is thick enough. I may have made it too thin. Well, let's see. Because the one thing that will keep this from going too far is the back cover here. Because once this is on there, it can't travel backward. That cover will prevent it from doing that. Let's throw some better light on that. We have to get a better. Oh yeah, that's much nicer. Okay. All right. So theoretically, now if I want to be even more anal than I am, I could check and make sure that these all look good. But I know I put my grounded one here. But let's just double check. And that's the other thing I do like to do is, once I've got it in place, I want to confirm that it's working. And then 0.5. And so now if I go from here to here, yep, and yep. So that tells me a number of things. Number one, it tells me that I don't have a short. Nothing's shorted. Number two, it tells me I've got it wired correctly, which is probably as important. Okay. And I have got these big guys for some serious washing. There we go, I think. Alright, there's that. Fun. Well, I really hope I don't have to do this one again. This is a pain. Alright. Maybe I can get in here with these and get it down where it belongs. Back for the more leverage. There we go. Fun. There. Alright, I think that's in there good. This is sturdy, it's not moving. Alright. So now, you see how much fun I have working on this. Yeah, I can do that now. Alright, I think that's close enough. It's not going anywhere. I kind of like to make it look like it's never been worked on, but it's probably not going to look that way, but like, that's okay though. Alright, so I checked everything. I know now that, and then I know that that matches this, which is what I wanted, because that's what I measured when I was checking that out. So this is messy stuff. Try to keep the mess down to a minimum as I'm working, but alright, so I'm not going to show you my repair job on the other one. I wasn't really going to show you repairing one of these, but I thought, well, what the heck, why not? Alright, so this one should be right. The one up here, unfortunately, is not. So I have to flip this around so I can get that one and redo it. And that means I got to figure out all over again what wires go where for real, and then recreate this. I really, really, really wish. I mean, it's so simple to use this to check to see how something like that is wired in. And I just didn't think to do that. Hopefully I remember. This radio is a challenge because, number one, I've never worked on one of these. I've worked on my Atwater Kent, and that one was interesting because there was one of their sealed boxes that they told you what, in the circuit diagram, they told you what size the capacitors were, but you kind of had to guess. Because when you got into the actual radio and you're trying to figure out, well, which capacitor goes where, you really didn't have the information that you needed to figure that out. So, anyway. Alright, so I actually did use my cell phone, took pictures of this. I am going to make sure that those pictures agree with what I see here. But I'm pretty sure this one goes here, that goes there, and that goes there, and I've got 3 of these wires. Whoops, darn. I'm pointing at stuff and you can't see it. Alright, so I think pretty sure this goes here, that goes there, this thing goes over there. I've got these 3 wires that go there, and I actually should start from the bottom, as I recall. Or do I want to do that? This is so much fun getting everything together. I'll figure that out. I won't bore you with that. Definitely a pain in the neck to do this. I definitely know a lot more about how this thing is wired now, how it's put together. But this is new to me. I've never dealt with a radio that was set up like this. I knew about this, and this is the thing that really attracted my attention. The 1, 2, 3, 4, 5. The 5 tuners that it had in it. I just can't believe that anybody thought that this was the right way to do this. Talk about over-engineering and over-complicating things. Wow. Pretty amazing. When we look at, well, even the Atwater Kent with all of the potato slicers in a row, that was the right way to do it. This is just nuts. And it's a cost. And this is not the first version of this radio. They had, I'm pretty sure they had a 1929 version. I think this is 31. I think. Do I have that information? I don't know. But in any case, I think this is newer because it's got the newer tubes. This has the 24 tubes in it. The other radio, the 32, had the 26 tubes in this, 4 of them. And the 24 tubes are, well, they have indirectly heated cathodes. The 24s do. The 26 were directly heated. So I'm assuming that the radio using the 24s was newer, but I don't know. I need the advantage of indirectly or directly heated is they heat up faster. The disadvantage is that they could be noisier and hum more. So anyway, all right, I'm going to bail out, and then I've got the next thing I've got to do is I already know I've got at least one resistor in here that's not the right value anymore, and they're all pretty much behind this. I know that this one down here is the right. It's supposed to be a 28K. It's 38K. 38K. That's just obviously not good. So I got to pull that out and replace it. But I'm betting every one of these is probably bad because the ones behind here, I believe, some of them are the ones that have the solder, the big torpedo-shaped solder head on them. They're older than these, which leads me to believe that this is new. In fact, all 3 of these may be new, but I'm not sure about that. This is interesting. I haven't seen one of these with a label on it. This one tells you that it's 1 meg ohms, and I've never seen one before. But now I gotta find out if this one's the right value. I have a feeling, well, this is newer than that one, but these go bad too. In fact, one of the things that happens with these is that the solder joints on the end fail and make bad connections. And then they become random, which is also great fun to fix. Alright, I shall return. Alright, well, I was going to end this video prior to this, but I ran into some stuff that's caused me to rethink that, because I need to order parts for this because I don't have what I need. I am also going to be putting my amplifier on the bench. That's the next thing I'm going to do. Part 4 is going to get into that. I didn't want to put this on the beginning of part 4. Also, I'm expecting that I may need to order parts for the amplifier. Oh, and I put these two covers back on because as I'm working above this, solder and stuff can get down on this, and I'm not happy with that. Oh, this is working tremendously. Much better. It's just very free, and so I'm happy about that. So, but before I digress, let me mention some of the things that I've run into. It's kind of strange, but then, you know, it's a 90-year-old radio, and who knows who's been playing in this. Let me see here. I want to show you. All right, this is what they call the resistance board, resistor board, whatever they call it. I think that's what they call it in the information. Some of these resistors hide behind here. This is one of them. And then I had this one, which I'm fairly certain was added later. Went from here to here. And then this one went from here to here. These two resistors don't show up on the circuit diagram anywhere. And this one in particular doesn't make any sense, because this is a filament wire. This goes to the screen grid, I believe. Is that pin 3? Pin 3. Detector tube should be, let me see here. Pin 3. Yeah, screen grid. Now, I don't know what they were trying to accomplish, but normally, in fact, let me just, let me put this over here. Oh, did I mention? I don't know if I mentioned this one. This is supposed to be 1 meg. It's 2.5 megs, so it's way over. Let's see. Is this one actually? Is this one? I know I have at least 2 dead resistors that are just open, completely open. The green with black, that one is erratic. It's very. And what's interesting is, and I tried to duplicate. Somebody had tried to solder this together to try to get this to work. When I tried to measure this, it was very erratic. And then I tried to heat it up and try to make it better, and it fell apart. But, yeah, nothing. Dead. Alright, but I wanted to see if any of these were any good, because I don't remember now. So, this one, dead. I'm pretty sure this is 1.5, that's dead. So 3 out of the 4 resistors are absolutely dead. And the 4th one is way out of value. Alright, so let's see if I can explain why. Oops. And this is another reason to, well, I say, by having gone through this like I did, like I have, and finding these problems now, that means I don't spend time later trying to troubleshoot why it doesn't work, because I'm finding it now. So let's see if I can show you what I'm dealing with. Alright, I think this is it right here. It's my detector, yes. Alright, so the 1.5 meg resistor goes between the screen grid down to this connection, which goes over to the coil and so on. And then it also goes down to this volume control. I need to go back and review some of my electronic information, training information, because I don't know exactly what they're doing here, because it's kind of funky, because you've got this connection that goes all the way over here, which goes to a cathode, and you've got these coils, which I guess are called stabilizing coils, and that one goes up to the cathode, so I'm not quite sure what they're doing. But anyway, but here's the issue with this one, this one, yeah, this one, and this one right here. The black and green one goes from the filament over to here. So this, if you follow this down, it goes to, yeah. So there's no rectifier. Whoops. This is just straight from the filament coil. It goes straight up, goes through here, goes into the tube. So this is AC volts right here. Unlike some radios, which if they have if they have directly heated cathodes, they tend to want to use DC volts for that. But because these are indirect heated, they can use AC, and they did. So what they've done is they've taken, and this was 2 volts, 2.1 volts on this. So they're feeding that AC voltage through a 5 mega ohm resistor, is what the color code tells me. I can't measure it because it's dead. But they're feeding that resistor over here to the screen grid. Now this screen grid, I believe, let's see, where are you? Screen grid voltage. Got so many papers, this paper. Where are you? Okay, yes, screen grid. On that tube is 3.4 volts. So you're taking a 2-volt source and hooking it up to this, which should have 3 volts. Now, part of the problem that they were trying to solve might be because this resistor had given up the ghost. Now, what's really odd about that, though, is that they took, let's see, what resistor? Yeah, so they took that coil and, okay, so they took another resistor, they went to this coil, went from this coil over to here. Now this is a plate, and I think this has around 50 volts, am I right? Just looked at those voltages. Plate voltage, 67, no, 50, all right. So at this point you've got around 50 volts. And they hooked that up over here. It's DC volts, and it is a 1 mega ohm resistor, so I don't know how much voltage was being dropped. So I don't know how much was actually being sent here. But I think somebody was trying to fix the fact that this resistor had gotten dead. So I've removed those. I'm going to put back, I'm going to put the circuit back the way it was supposed to be, and then I'm going to check the voltages and see if everything looks good. If not, then I'll have to go from there and try to figure out why it's not good. So somebody, and this was particularly funny because this one, well, this was already bad. This was already bad when they put it in the radio, and like I said, they tried soldering it. This is their soldering work down here. They tried soldering this together, trying to make it work. So I'm kind of wondering if they put this resistor in and it didn't work, which was probably a good thing because you most likely would get a lot of humming and you wouldn't get the voltage you really want at that point. So I just don't know. Took me a little bit of thought in just considering what was supposed to be where. And I'm especially puzzled about this because 50 volts down here, and even if they were to connect from here down to here, this is only 97 ohms, I think, this coil. So that's just not good. So I'm going to put this back to the way it was supposed to be, and I'm going to order it. So back to my point. I am going to stop working on the receiver part of this now, and I am going to switch to the amplifier for a couple of reasons. Well, the primary reason is I don't want to order parts for the receiver and then find out that I have to replace more parts in the amplifier. So regardless, there's going to be a little bit of delay in me putting up the video on this unit because I need to order parts. But I want to look at the amplifier and make sure that I have a complete order to send in rather than piecemealing it, which costs more in shipping costs than I like these days. So I'd like to keep those at a minimum. So hopefully I will see you for part 4 as we dig into it more. We'll see how well my speaker repair did, and hopefully we'll get the thing actually making some sound, making some noise. Looking forward to that. Kind of anxious to see how this thing works. I'm told this is a good unit, that it has good performance. We'll find out.